Okay, when you are determining domain from just the equation, right? We don't have a graph of this. You need to be concerned about two things. One, do I have a variable in a denominator? If I do, I'm never allowed to make that denominator. I can't let it equal 0. So I figure out what would make that denominator 0, and then I say, okay, you cannot be in my domain because you're going to make the denominator break. So that's one concern. My second concern is if I have any even index radicals. In other words, a square root, a fourth root, a sixth root, an eighth root. Those can't be negative underneath the radical. So what I do is I take whatever is under that radical and I set it greater than or equal to 0. I solve, and that's what I'm allowed to have. That's what I can plug in without things breaking. And then if I have both of those situations, I just have to stop and kind of think about, okay, what's going to work for everybody? And that would be my domain. So if I'm looking at number 1, I don't have either of those situations. I don't have a variable in the denominator, and I don't have a square root. That means I can plug in whatever I want. So all reals would be my domain there. When I hit one like number 2, I do have one of those issues. I have a variable in the denominator, so all I have to do is not let that denominator be 0. And the only number that would make that happen is -5. So that's why my domain is everything except -5. If you're going to write that with function notation, you certainly could. So I can have everything except -5. Remember we were sketching on the number line, and that can help you set up the interval notation if that's what you want to do. If I'm going to graph everything that's not -5, doesn't it look like that? Right? So in interval notation, I'm coming from -infinity, and I'm getting up to -5, but then I have to hop over the -5 and then go off to positive infinity. So you could have given your answer in either of those ways. It doesn't matter. 3, I have the other scenario. I have a square root, so I can't let this go negative. So what do? I take whatever is under that radical and I set it greater than or equal to 0. So when I solve this, I get that. This is what I'm allowed to have in my domain. If you're not sure, try some numbers. Why did I write 0? I don't know. Add 15 to the other side. There should be a 15 there. There we go. So try some numbers. Try a number that is greater than or equal to 15. Try 15, right? If you pop 15 in, 15 minus 15 is 0. Can you take the square root of 0? Yeah, you can. It's just 0. So that's fine. 15 should be in my domain. It's totally fine. If I plug in 20, sure, 20 minus 15 is 5. I can take the square root of 5. I don't know what it is, but I can do it. Right? It comes out with a number. What I can't do is something that's not in this range. So if I tried plugging in a number that was not greater than or equal to 15, 10. 10 is not in this range, right? So if I plug in 10, look what happens. 10 minus 15 is -5. Can you take the square root of -5 in the real number system? No, you can't. You've broken it. So you better make sure that your answer does not include numbers that are less than 15, because they won't work. Those are the only ones that work. Your domain is what works. Okay, 4, I have both problems. I have a square root and I have a variable in my denominator. So this guy, I can't have 4. So I know that's part of it. Whatever I'm going to say is my final answer cannot include 4, because 4 makes things break. Up top, I'm going to set that greater than or equal to 0 and solve, so I get this. X is greater than or equal to 1. So I need both of these. He's one of my favorite children's authors. Okay, so 1 and 4. I need both of these things to happen in order to work in this. So let's try and graph this. I need all the numbers that are greater than or equal to 1. Oh, so that would be shaded in, shaded this way. But I cannot have 4 either. So here's me not having 4. So I want what works for both. Well, what works for both? It does work at 1, right? 1 works for both of them. I'm not going to include anything over here because it doesn't work for both. All this works for both, and then I just have to hop over 4. But then all this works for both. So that's what I need to represent. Oh, and that's 1. So I'm coming from 1 up to 4, but then I got to hop over the 4, and then I can go off to infinity. So there it is in interval notation. If you left it like this, that's fine too. And try the values, for Pete's sake. Plug in numbers that are in this range, and then plug in ones that aren't in this range, and see what happens. So if I pick a number from 1 to 4, say 3, 3 should work. Yeah, that's fine. I can have a negative in my denominator. Sometimes, I don't know, every now and again, like, someone thinks that you can't have a negative in your denominator. Sure you can, why can't you? The only thing you can't have in the denominator is 0. Negatives are fine. So, yep, that's cool. I can pick a big number. Yep, they're fine. Pick a number that's not within these values, and it's going to break. Does that make sense? Okay. 5, the only concern is that x in the denominator. It's not allowed to be 0. This up here doesn't matter. Who cares? Remember, the only 2 things I care about, a variable in the denominator or a square root. And this is not either of them. That's the only thing that concerns me. So that means I just can't have 0. And then the last one, you got a double whammy here. I can't have this denominator equal to 0, and I also can't have x squared minus 9 ending up being negative because it's under a square root. Okay, so let's sort of piece our way through this. I can't have it equal to 0. So normally I would take x squared minus 9 and set it greater than or equal to 0. But because it is in the denominator, I need to get rid of that or equal to bar. Right? Because it actually can't equal 0. Because if it does, I'm in trouble. You with me so far? All right. So now, with these quadratic ones, it really is easiest to just sort of sketch a graph. X squared minus 9 is just a parabola dropped down 9 units. It's going to cross at 3 and negative 3, right? If you factored this and solved, I know I would hit here and here. So I need to look at this and ask myself, okay, this thing cannot be negative. Where is this function negative? In between negative 3 and 3. So I can't have this in my range. What can I have? This area and this area is totally fine. So where is that? That is when x is less than negative 3, greater than positive 3. Can I do or equal to? No, because that's what's going to turn this into zeros. Right? If you plug in 3, doesn't the denominator turn into a 0? Yes, which is a big deal in the denominator. If it wasn't in the denominator, I wouldn't care. But it is. So that's how I end up here. Does that make sense? Everybody's good? Okay, I didn't mean to do all of them, but I did. So there we go. How about round 5? So round 5. Which of the following equations are functions? So for these, you basically want to get y by itself. When you get y by itself, if it's equal to a plus or a minus, you know right away it's a no. Okay, so let's do a couple of them. So number 1, for example, I'm going to get y by itself. Let me grab another sheet here. I'll just do it at the bottom. Okay, so let's recopy it. X squared plus 5y squared minus 16. Oh, you know what, too? There's a typo. That's supposed to be equal 16. So that might have thrown you off on the first one. I'm so sorry. Yeah, that's not supposed to be a minus, because that's not even an equation without it. Right? Okay, sorry. All right. Now we have this. So I want to get y by itself. So let's minus that x squared. Oops. plus 16, we'll divide by 5, divide by 5, okay, y squared equals negative x squared plus 16 divided by 5. To get y by itself, though, don't I now need to take a square root? Right? I need to square root both sides. And when you take a square root, what do you need to remember? Positive and negative roots. This is not a function. Why? Because when I plug in a value for x, say I plug in, oh, I don't know, 2. If I plug in 2 for x, right, what's going to happen? I'm going to get some answer here, but then I get a positive and a negative value. So when I plug in one thing for x, I'm getting out 2 answers. That is not a function. When I plug in a number for x, I can only get one number out for y. And that's not what's happening here. If I plug in one number for x, I'm going to get 2 values. I'll get a positive whatever and a negative whatever. Does that make sense? So when you get y by itself, and there's multiple values, so if I plug in x and it's going to come out with 2 different y values, that is no longer a function, it has broken. So that's a no. Does that kind of make sense? Now when I go to do number 3, you've got 6x minus 5xy equals 7. Okay, so if I get this solved by itself, solve for the, oh, what am I doing? There we go. Let's minus that 6x over, divide by the negative 5x. So now I have y by itself. If I plug in a number for x, say, I don't know, say I plug in 1, right? I'm going to plug in 1 there, I'm going to plug in 1 there. When I evaluate this, though, y is only equal to one number, isn't it? I don't know what that number is. This is going to be some weird number. Actually, it wouldn't be that bad. 1 over negative 5, negative 1/5. So if I plug in 1 for x, negative 1/5 came out for y. Not a positive 1/5 and a negative 1/5 or something like that. I plug in a value for x, only one number comes out for y. That is a function. 5, this one's easy to think about because you know what the graph of this looks like. What does the graph of x equal 9 look like? It's straight up and down, right? Does that pass the vertical line test? No! When I plug in a value for x, you get an infinite number of values out for y. So that's a no. What if it had been y equals 9? Would that have been a function? Yes! Are these a little bit better now that you understand what you're supposed to be doing? Get y by itself and see, does it equal multiple things? So, I don't know, real quick, we can do 7. If I get y by itself, I'll just subtract everything over to the other side. Wouldn't that get me y equals, let's see, there would be a negative square root of x plus 5. And then if we added that 4 over, I'd have a plus 5. What do you think? Is this a function, yes or no? Yes! When I plug in a value for x, say I plug in, let's make our lives easier. Let's say I plugged in negative 5. If I plug in negative 5, I get square root of 0, which is just 0. Negative 0 is just 0, right? Plus 5. When I plugged in negative 5, I got out 5. I plugged in one number and I got out one number. If I plug in 10, if I plug it in, I'm going to get out only one number. I don't get multiple numbers back out like I did for this one, right? When I plugged in a value for x, I got a positive value and a negative value. That's not happening here. So, yes, that guy is a function. Is this all right? Any other ones you want me to do on this round, or we're okay-ish? Okay, round 6. Anything on round 6 anybody wants to talk about? 7. What'd you say? Oh, yeah. Anybody need anything on 7? Yeah? Anyone in particular?
All of them.
Did you say all?
Yeah.
Okay. All right, yes. So round 7. All right. So if we look at the first one, me personally, and maybe you don't operate this way, but I think it's a lot easier to figure out what these boundaries are first. I look, where is my graph splitting? What's even going on? So I look at this and I see, okay, my graph changes right here. It also changes right here. And then I do kind of have one other spot. This is going off to infinity, but this one's not. So I do kind of have a change there because my graph went from nothing to beginning, right? So I do have something going on right here. So I do need to take that into account. If that had been an arrow and it just went on to infinity, I wouldn't really care about it. But I do have something happening there. So I might start with that. Figuring out, drawing those lines where I have changes in my graph. So now I need to express my interval. So we're always going to work from left to right. So the graph doesn't even exist over here. I don't care about this region. Here, so what are my x values here? This is -1, -2, -3, here's -4, and that guy is 2. This first part of my piecewise function only exists between -4 and -1. Do you see that on the x-axis? -4 to -1. So that and they're both closed circles when they hit. That first boundary is going to be right there, in between -4 and -1, with bars underneath both. That's where he exists, in between those two values. Now, to figure out this part that's under my finger, I just have to figure out, well, what's the equation of this line? How do you find the equation of a line? Well, you have to have the slope. So you got to find 2 good points and figure out what the slope is. This one's pretty easy. Looks like the slope is 1. Your other option is you can take any point on this line and plug it in using point-slope form. Right? Pick a point. You have the slope. Plug it into point-slope form, and then just rewrite it in slope-intercept form. Your other option is if you can easily figure out what the y-intercept is, okay, then I can just go right to y equals mx plus b. Lucky for me, since the slope is just up 1 over 1, don't I know if this graph had kept going, it would intercept at +2. You see that? So now I have everything I need to write that in slope-intercept form. Slope is 1. The y-intercept would be 2 if it got that far. So that means under my finger, I should be writing 1x, or just x, plus 2. Yes. Does that make sense? That's the equation of this line, but it only exists from here to here. Okay, great. I have that first part done. Now I move on to my middle area. So again, let's figure out the boundaries. It's going from -1 to a +2. Notice that it's open at -1, closed at +2. So that means I have to write my boundary like that. There cannot be a bar underneath that in between the -1 and the x, because it's not equal at -1. Okay, so there's my boundary, and then again, I just have to come up with the equation. So let's start with the slope. Ooh, we got lucky again. This slope is nice and easy. It's just a -1, right, because I'm just going down 1 over 1. And this one just so happens to cross the y-axis at 2. So that means this equation's got to be -x plus 2. Yes. And then the third one, he only exists when x is greater than 2. Not or equal to, right, because he's open. So greater than 2. And then I just got to ask myself, well, what's the equation of this line? It's just perfectly flat, so what do I write? How do you write the equation of a flat line? Yeah, it's just y equals, and I happen to have my y is -3 right there. So I just write -3. Does that make sense? Yeah, everybody's okay? So then when I go to do this on the second one, I again see that I have, now I don't have, this one goes on forever, so I don't have to worry about that. I have a split right there, I have a split right there, And then this one does not go on forever. He does end, so I have a change right there. So I set up my intervals. The first one is existing when x is less than -1. This guy is existing in between -1 and +2. And then this guy only goes from 2 to 5. So there's my first boundaries. I double check that the middle guy has both ends open. Yeah, okay, everything looks good. And then I just pop in my equations. They're 3 horizontal lines, so I just pop them in. 4, -1, and +2. Is that okay? And then the last one, I have a change happening right here, and I have a change happening right here. But I'm not going to have 3 branches because nothing's happening in the middle, right? There's nothing going on here, so I don't need to include anything for that. So this guy, he only exists when x is less than or equal to -1. So there's my first boundary. And then this guy only exists when x is greater than or equal to +2. So there's those 2 boundaries set up. Now let's just figure out this guy's equation and this guy's equation, and we'll be good. So I'm looking at this one. What's the slope of this side? Yeah, his slope is +1, right? He's just going up 1 over 1. So I know his slope is 1, and then, so if I kept going, I know he would intercept the y-axis at -1. So there's his slope, or his equation. A positive x minus 1, because the slope is +1, and if he kept going, he would intercept at -1. Yeah? And then this one, a little bit trickier. So start off by finding your slope. So there's a good point, and then here's another good point. So that slope looks like I'm going down 1, 2, 3 over 2. -3/2. You agree? So what I can do is I could keep that slope going and see where I would intercept the y-axis. It's not that far off, so I need to go up 3, back 2, up 1, 2, 3, back 1, 2. And that would land me on the y-axis. So where am I? 1, 2, 3, 4, 5, 6, 7. Looks like I'm intercepting at 7. By the way, if you had one that you could not do this on, 7's not that far off the grid. But what if it intercepted at 27? That's way too far off the grid. You have to use point-slope form. You have a point on the line. You have 2 good ones. Pick one of the points and you know the slope. So use point-slope form and then just rewrite it in y equals mx plus b. So there is your second equation. Does that make sense? Okay. Alrighty. So that was 7. How about 8? Anybody need help with 8? You got it. Oh yeah, domain. This time we at least have pictures. Whew. We don't have to do all that deciding if we care or not. We just have to look. Oh no, and I hole punched this away. So I don't know. Let's see. I think that's supposed to be an arrow, because it would matter if it just had a dot or not. So yeah, that. Oh, it is a dot? Oh my gosh. Oh, okay. So yeah, sorry. Hole punched out, but it's a dot. Oh, it's only hole punched out on mine, because mine, I copied like a whole page. Yours isn't even hole punched. So you know. Okay. I'm like, how do you all know that it's so? Got it. Okay. All right. So anyway, so we have a closed out there. So I'm talking about domain now. So you're going to start on the left. There's no values of this graph over here. Nothing, 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 until I hit 4. -4, right? Domain is my x values. So I don't have anything until I hit an x value of -4. That's my first value. So I'm going to go from -4. Now, when I hit here, there is a change in my graph. But I still have a value at -1, don't I? Yeah, it's right there. Do I have a value at -1/2? Yeah, I do. Right? It's right there. So even though it jumps, there's no gap. Right? There's nowhere for me to fall off this. If I'm going from left to right, here it's like I took the elevator up and now I'm going to slide down. There's no gap. So all this is fine. This is fine. Now when I hit here, I'm just going to take the elevator down. I'm going to go this way. If I need to walk from here to here, there's nowhere for me to fall. There's no holes. Whereas in this one, if you're trying to walk from here to here, well, how the heck are you getting over there? Ah! You better do a big jump or something. I don't know. This one has a break in its X value coverage. Does that make sense? Do you see that? This guy doesn't. It's just, I'm just moving different levels. But I didn't fall down. Anyway, so his domain starts at -4 and then goes off to infinity. So this graph covers X values from -4 off to positive infinity. So I just want anything greater than or equal to -4. If you do an interval notation, you'd have -4 off to positive infinity. Now I do the same thing with range, but range, remember, is your Y values. So now I start from the bottom and I move up. I don't have any Y values down here at all. None, 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 until I hit -3. So I do have range values at -3. And then a lot of you made the mistake, I think. You just said, oh, okay, well, I have range values from -3 all the way up to +3. No, you don't. You don't have a range value of -2.5. Do you? No, there's a gap here. There are no range values right there. So I have range values at -3, but then I don't have any until I hit -2. And then once I hit -2, I have them all the way up to +3. But I have this jump here. So this is how I have to write my range. I have -3, and then I have everyone from -2 up to 3. Make sure you leave 3 open because I don't actually have a value at 3. I have everything up to 3. Does that make sense? Yeah. I don't have a value of -3 right there, but I do right there. Yeah. Yep. Yep. So everywhere else except right there, but I do have Y values of -3. Okay, let's take a peek-see at this one. So again, I'm going to start all the way on the left-hand side, so I'm coming from -infinity. My goal is to walk from one end of the grid to the other. Let's walk, 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 walk. Here, I take the elevator down. I walk, 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 walk. I take the elevator up. I walk, 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 and I made it all the way without any gaps. Do you see that? Made it all the way, no gaps. This guy came from -infinity, but I do stop here at +5. So my domain, everything from -infinity all the way up to 5. If you like that method, trying to walk from this end to this end, do the same thing with domain, just turn your paper. Right? Now I'm trying to walk from this end to this end. Okay, I have nowhere to walk here. I don't have anywhere to walk until I hit right here, which is -1. And then, I have nowhere to walk here either until I hit this. Nowhere to walk, nowhere to walk, nowhere to walk until I hit this. So the only places I have some support are here, here, and here. So at -1, 2, and what's that, 4? So my range is only at those values. Does that make sense? And then the last one, we already talked about if I'm trying to walk from the left to the right, this goes off to infinity. Okay, so I can walk all this way, but then I have to make a jump to get over here. So there's a break in my domain. Nothing is represented there. And then I have this. So my domain came from -infinity all the way until x was -1, and then I had to make a jump from 2 off to +infinity. Now let's try for the range. So if I'm going to do that same thing, just turning my paper this way, let's see. Plenty of things for me to walk on here. I came from negative infinity. And then, well, look, now remember, this line keeps going forever. So once I get to the end of this, I can take an elevator down. And I can keep on walking, keep on walking, keep on walking. I can't quite get to the end, but I can get everywhere from here to here with no gaps. Do you see that? But here, I can't go past that. So I can come from negative infinity all the way up to positive 4. Does that help? Maybe? Okay. All right, round 9. Good, bad? Don't be sad. What is even this one? Oh, areas of, yeah, our different intervals. The only thing that I wanted to mention about this to remind you of, when you are talking about an interval of increasing or decreasing, it doesn't include the turning point. So for example, I have an area of decreasing right here, an interval of decreasing from this point to this point. I do not include -1 and +1 even though those dots are closed. I know that they're closed, so I know that you want to include them. But at that exact point, I'm not increasing or decreasing. That's the point where it's changing. So I don't include that over my interval of increasing or decreasing. So if you look, that's why you have an open parenthesis there. Same thing for these ones, they're open parentheses. Even though those dots are closed. Does that make sense? So the interval does not include the point where things are changing. Closed or open, doesn't matter. Does that make sense? Otherwise, we're okay-ish here, I think, maybe. Well, I don't know. You tell me. Yeah. Sure. So, domain, I can walk all the way from the left-hand side to the right-hand side with no breaks. Everything's fine. So my domain is all reals. My range, I can't walk over here at all, but once I get here, if I follow this path, I can walk forever. You could go this way, but why? I can go forever this way, so I'll just go this way. So my range starts at 0 and goes off to positive infinity. So I can have anything greater than or equal to 0, or in function notation, 0 to positive infinity. Where am I increasing? So that means as I trace my graph with my finger, here, what would we call this? Constant. Here I am decreasing, and then here's the area where I'm increasing, right? Because my finger's going up. So this interval I'm increasing on. Okay? So interval of increasing, well, it starts at 1 and it goes to off to positive infinity on my x in the x direction, right? But again, you don't include that point. I know it's closed, so you feel like you should include it. But the interval doesn't include the turning point. So greater than 1 is where I'll be increasing. Decreasing, I'm only decreasing right here, in between -1 and +1. But don't include either endpoint. So that is where I'm decreasing. Where am I constant? I'm constant from negative infinity up until I hit -1. But don't include -1 because I'm changing right there. Okay? Now, relative min and max. So a relative max means it's the highest point of its little area. Okay? So if I take a look right here, it's certainly higher than the right-hand side. And then we had talked about the left-hand side. If it's equal, it still counts, right? So that guy is going to be referred to as a relative max. And then this guy is going to be a relative min. We never are concerned with the endpoints. So even though this endpoint certainly will get higher than that relative max, it doesn't matter. The endpoints we ignore. We're only looking at what's going on kind of in the middle of the graph. So where is this happening? He happens when x is equal to -1, whereas this one happening when x is equal to +1. Does that make sense? Okay. So there's 9. 10 you were supposed to graph on the graphing calculator, I believe. Which, just while I'm thinking of it, your test tomorrow, on the first part, you can use the scientific calculators, which are the ones on the cart, so these ones. And then you're going to turn it in and then pick up the graphing calculator page. So then you get the graphing calculators, which are on the wall. I left all that for the sub, but just so you know that you're going to have 2 parts. Alrighty, so you were supposed to graph this thing. Hopefully you got this looking graph. Domain. If I'm trying to walk from the left to the right, I'm walking, everything's fine. Uh-oh, there's a gap here. And then I pick it up over here. So my domain is not all reals because I can't get all the way across, but I can get from everything that's less than -1 or greater than or equal to +1. So there's my domain. My range, same thing. I don't get anything over here until I hit 0, and then I can go off. So my range has to be greater than or equal to 0. Where am I increasing? This part is increasing, this part's decreasing. I know it doesn't ask you for a constant, but I don't have a constant here. What else? Okay, relative max. Nobody's a max here. This guy's not higher than the points around him, neither is he. The endpoints, remember, don't matter. So I don't have a relative max in this example. What I do have are 2 relative mins, one there and one there. So they are both relative mins. X-intercepts, I hit at +1 and -1, and I never hit a y-intercept, so I don't have one. We're good? Oh my gosh. Some of you are like bored to tears. Sorry. All right, 11. Odd and even, and either. How do you tell? Someone tell me how you check for even. Yes.
You set x to like negative between.
And then what?
And then see if it matches the original code.
Exactly. So if I want to check for even, I plug in -x, simplify my function, and see if it matches the original. If it does, that means it's an even function. When I'm looking at the graph, what does an even function look like? They're symmetrical over what? The y-axis, right. So if you had a graph, or if you, you know, some of these, you know what the graphs look like. Like number 2 is just a straight line, right? So you could graph that if you wanted, right? And if it folds over the y-axis and matches up, then it is an even function. And then odd, that's over the origin. So remember, odd, origin, they both start with O. And to test for the, if it's odd, first I'm going to do the even test. And then to test for odd, I just take that and pop in -y and see if I can get it to match. And if I can't do either one, then it's neither. So, were these all right? Did you get these correct, or any questions on this? No? We're good? Okay. And, oh, last one, 12. Almost there, guys. Ah, yes, average rate of change. So, remember how to do this. Do you remember? Oh dear, well, you're going to need to know this. So, I have some interval, right? So I'm going to have some function, blah, 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 blah. And it's going to, oh, you can't even see that. I'm going to have some function, and I'm going to set it over some interval a comma b. So to test for the average rate of change over that interval, you need to do f of b minus f of a, all divided by b minus a. And that gives you the average rate of change. Over that interval. Does that make sense? So I just start off with whatever that value is, plug it into the function, see what I get out. I take a, whatever that is, plug it into the function, see what I get out. I take those two values and I subtract them, and I divide it by whatever b minus a is. Okay, so here were your answers. Is there maybe one that anybody wants me to do out? You got it. So, I was going to do it at the bottom, but I'll just do it on the sheet. All right, so let's rewrite the function here. F of x equals absolute value of x minus 2 plus 4. And my interval this time is negative 2 to 0. All right, so I need to take the b value and plug it in for f. So I want to find f of 0. 0 minus 2 plus 4. So that's going to be absolute value of negative 2 plus 4. The absolute value of negative 2 is 2, and 2 plus 4 is 6. Okay, so I have that one. Now I do f of negative 2. Let's see what comes out. Negative 2 minus 2 plus 4. So that's going to get me a negative 4 in there. What's the absolute value of negative 4? 4. 4 plus 4 gets me an 8. So, great, I have those two values. So now let's just pop them into that formula. So the average rate of change is f of b minus f of a, all divided by b minus a. So be careful with your signs, because that's going to be minus a negative 2, right? So that turns into plus. So I end up getting negative 2 over positive 2, or negative 1. All right, guys, what do we think? We're all right? Okay, so let's stop this video before it stops on me.